Hello, my name is Mark Belos-Lutsev, and I'll be covering data security and encryption today. So why do we need data security? Well, most importantly, data has value, and it's important to secure ourselves and our information against malicious actors like hackers, because they can do stuff like data theft, ransomware, industrial espionage, which has been rising recently. And also, another topic that we've been covering a lot in this class, and we know, is that privacy is important. So the main ways to defend ourselves and our data is through antiviruses, such as McAfee, Norton, Bitdefender, and others. They work by defending against malicious actors like hackers and blocking threats that are unknown to the system or to their databases. Another way to protect ourselves is by using HTTPS websites rather than HTTP websites. We'll be covering that a little bit further, but just know for right now, S stands for secure. Another way is two-factor authentication. We know that from the recent stuff we've been doing for our accounts for Cal Poly, two-factor authentication gives us an extra layer of defense against someone who's trying to brute force their way into our accounts. There's also encryption of hard drives, which is encrypting and changing the stuff inside the hard drives so someone who doesn't have the decryption key can't read the stuff inside your hard drives. And lastly, probably the least effective but a very available source is by choosing and vetting websites that you enter your information to very carefully. This small factor has led to a lot of different people losing a lot of information. So it's important to vet these websites to see if they've been tested for data breaches or sell user data. As we all know, some large tech companies would rather sell our user data than to keep it safe. So encoding messages. As I said, I'm going to be talking about encryption, and this is what encryption is. So as we said earlier, HTTPS versus HTTP. HTTP is a web protocol that sends unencoded messages as plain text, and it can be easily decoded and it can be easily read by anyone who can access it. While HTTPS encodes them when transferring information to the website, making it harder for someone who doesn't have who has the decryption key to find out what information is being sent. This kind of information can be passwords, usernames, important vital information, for example, your social security number and whatnot. And also another way that we can defend ourselves is by encrypting email services. Outlook has this, TLS, which is an online mail service, has this. These are online services that we can use, but Outlook can also be as an application. And the way how these email services encrypt and decrypt messages is by using PGP encryption, which we talked about earlier. They use the public key and decryption key to encode and decode them. So encrypting files. What can you do to encrypt your files? Well, luckily, we can encrypt our files on the most popular OSs like Linux, Mac, Windows, and whatnot, and with other third-party applications. Windows itself has BitLocker, which is installed in Windows 8.1 and over, and most of us should probably be using not Windows XP. So we already have an application on Windows that can encrypt our own partitions of our drives and whatnot. Mac OS X, which is, I assume, the most modern version of Mac, allows users to encrypt files using disk images, which is a way to single out certain files and makes it easy for people to encrypt those specific files rather than encrypting whole partitions of the drive. Linux, like Mac OS, also allows users to encrypt any of their files in many ways and makes it way easier than Windows or Mac to encrypt these files. The easiest way is to use hidden folders and encrypts it using the Linux GUI. And like I said earlier, third-party applications are also available to every OS, and they encrypt the user's files just as easily as the other ones. So as we saw in the Snowden video, he manually encrypted his files and sent it to the receiver. And one of the main encryption methods that are used today for HTTPS, for encoding emails, and many other encryption systems, this is the easiest one, is called RSA encryption. And it stands for Rivest, Shamir, and Adelman. These are the creators of the RSA, and it was made back in 1977 for, as you can guess, military services, and declassified in 1997. It is among the easiest ways to encrypt messages and to decrypt them. And as I said, most websites use it for HTTPS. You can find them in the information tab in Chrome, for example. It's very efficient because it uses uh, formulas to encrypt these very complicated strings of information. And they use modular math, is a simple way to say it, to implement them. So like I say in the slide, it is somewhat simple to implement, but it is incredibly difficult to find the decryption key for these. And as I say, it is extremely secure, and it takes computers around 1,500 years to crack a 232-digit key in 2012. Now, to put that into perspective, that was 232 digits in 2012. So 9 years later today, right now, we use 1,024 to 2,048 large digit keys. That is gigantic, and as you could probably imagine, it takes a long time. Even though computers are faster nowadays, it still takes a long time to decrypt those kind of keys.
Another way to protect your data is through the internet with a VPN. But before getting into what they do, let me set the scene. What happens when you open a web browser? Well, the computer communicates a request with something called a modem. The request then flows through the modem to your local phone company and out into the internet, which will get to the server it wants the information from. From there, the server gets the request, sends the information back through the internet into the phone company through the modem and back to your computer. Seems simple enough, right? Well, there's one little detail I forgot to add. The data rushing through the internet needs to know where it's going. It needs some sort of address from both the recipient and the sender. This is where the IP address comes in, which is a set of numbers ranging from 0 to 255 divided by dots, which was most likely assigned to the modem from the internet service provider, or ISP. These numbers are shown to anything the packets of information touch. Every router and every server knows the IP, and most web servers from sites like YouTube, Amazon, etc. will log the IP address into their databases along with what's being requested and what's being sent out. While this is most likely used for data analysis purposes, it is a bit concerning. What's even more concerning is that these IP addresses are assigned by blocks, meaning that people in your general area will also have the same IP address. These addresses can be easily looked up and can give your location on the country level, the city level, and sometimes even the street level. While this doesn't really do anything when it comes to going to websites like Twitter, it gets scary when you want to look up information on more sensitive topics like a mental illness or a morbid curiosity you might have. Most governments have a system where they can demand information about a person using a specific ISP on a certain day. Not to mention that public hotspots, which are used in places like coffee shops, are just a gold mine for information gathering. Almost none of the information sent and gathered in these areas are encrypted, which means internet messages, banking information, and emails can be compromised if accessed through an open hotspot. Now that you know the risks of normal internet browsing, let's get to what a VPN does. A VPN, or a virtual private network, is basically a shield for your internet request. It's normally used under the category of securely connecting a client to a larger network or provider. This was originally used by businesses to let employees access secure information over the internet while being remote, but it's now used by smaller businesses and individuals who want to protect their information while browsing the internet. VPNs use something called a tunnel protocol, which is a tunnel for data to go through. It makes a layer of security that instantly terminates the connection between you and the server when the VPN detects a sort of intrusion and instantly reconnects it using a slightly altered route or a completely different route to the same destination. Some VPNs even use a very specific low-risk route, which are considered as such through Submetric or through a partnership with a server operator. On top of this protocol, the data itself is also encrypted, and it goes even further by using non-linear data transfer methods, like breaking the data into multiple chunks and using a different route for each chunk. Another format that can be used is implementing dummy code in the information packet, so if anyone manages to get a hold of the data for any reason, they will only receive a huge jumbled mess of nothing. VPNs can also be a way to bypass any country-specific restrictions by using a VPN in another country. This is basically pretending to be in another country through the eyes of the internet. Overall, VPNs offer a higher level of personal protection and even the ability to access secure networks if you are in another country. There are some downsides to something like this, however. Most are minor, and one in particular is a bit concerning. Some pages don't really work properly when using a VPN, and content loading will be affected due to the encryption, decryption, and route changing the VPN has to do to keep your information secure. This can be fixed by having another browser installed for non critical use only. If you're working in an office with not so great wiring, packet loss can occur, which triggers the intrusion system of the VPN, causing constant disconnection and reconnection. The NSA has also been reported to flag accounts that search for things related to a VPN, so seeking out protection may actually lead to you being compromised by the government. And that is the basic rundown of a VPN.
My name is Raul Guerra, and today I'll be talking a little bit about the Tor browser, which is an anonymity network. Now, a little history about Tor. Since the invention of the internet, which was in January 1st, 1983, there has been a lot of concern about the lack of security and anonymity in a network. In the early 2000s, Roger Dingledine and Paul Syverson started working on a solution to this problem at a US Naval Research Lab. The result of this research was the onion routing, stands short for Tor, which relied on a decentralized network and an open source software. Although Tor became very popular among activists and tech savvy users, it was still pretty much hard to use for the average Joe. This led to the development of the Tor browser in 2008, which was a lot easier to use. This made it a lot safer and easier to access the internet to any user surfing the web. But how does the Tor network actually works? Well, Tor uses thousands of volunteer servers across the world and encrypt your data. These servers are called relays. When your encrypted data enters the Tor network, Tor automatically removes the header information from the packet you're sending, which could be used as a way to potentially learn information about the sender. Um, After all this is done, Tor encrypts the rest of the information in a process called wrapping. The packet is then sent through many of the servers, again called relays, towards the final destination. Each packet that's transferred from one relay to another, each time this happens, the packet is decrypted just enough, just for the relays to know where the data came from and where it's sending it. And before transferring to the next relay, Tor wraps it again. So this process of wrapping the packet every time that it's transferred for relays is what's the reason why we call this the onion routing, because there's a lot of layers to it. So let's see how this actually works with some pictures here. Let's say that Alice is the user of the Tor network, and she wants to send a message to Bob or Jane. So the first step is that Alice needs to obtain a list of the Tor nodes from a directory server. In this example here in the pictures, this is obtained from Dave. This green arrow depicts that the link between Alice and Dave is encrypted. So the list of the nodes is encrypted and is therefore safe. The next step is that Alice uses the Tor clients to pick a random path between the servers of the Tor network. So first Alice sends her packet to the first node, which is transferred to a third node, to a second and third node. Each time that this is transferred, again, the Tor network is wrapping and encrypting the packet that Alice is sending to Bob. Now you can see that between these transfers to the relays, the packet is encrypted, but at the end, between the last node and Bob, we have an unencrypted link. So we're going to talk a little bit about that later, but basically this is one of the things that makes Tor not 100% safe. Lastly, if Alice wants to send another request or try to contact another website or person, the Tor network automatically picks a second random path. It's not going to be always the same path as before, and that way ensures that this information cannot be traced back to Alice in the same way. Again, we see that at the last node, the transfer between the last node and Jane is unencrypted. So we previously mentioned that the Tor network is not 100% safe. Well, the truth is that, like any other system, Tor has its weaknesses. And there are a lot of people, many groups and individuals out there trying to access the information Tor is hiding for different reasons. Just to give you an example, in 2014, a government funded team of researchers successfully collected information from the Tor browser for months. Again, in 2017, a leak was found that easily made IP addresses of Linux and macOS users visible. There's a lot of malware out there in the dark web. But one of the reasons that Tor is not 100% safe is that because, as we saw in the pictures before, is that it only takes one bad exit node. Someone monitoring the packets being sent through the Tor network at that exit node to see your activity. How scary this can be. The problem is that they cannot track that packet back to you. So that's one of the safe things about Tor. So if you're just using Tor as your general browser and you're staying away from illegal websites, you should be okay. The reason that people is being tracked on the Tor network is mostly because the government tries to focus on tracking individuals who are linked to illegal activities. Because of the way the Tor operates, the government cannot track everybody, so they must be selective of who they spy on. And as a last note, beware of hackers. They are always roaming around in the dark web.
So moving into Linux. So what is Linux? Linux itself is not an operating system, it's a kernel. And although we refer Linux as an operating system for simplicity, that's what sparks some controversy. Some people call it GNU/Linux, or some people just call it Linux for short. It started out as a hobby project by Linus Torvalds in 1991, and it's famously known for its open source. And you can find the code base on GitHub with almost 1 million commits and over 10,000 contributors. And where's Linux? Linux is in smartphones, cars, supercomputers, home appliances, and enterprise servers. And since it's open source, it's literally always free. And compared to Windows, where it's close and you need to buy its key, and macOS, where you need to buy their hardware. Like I said before, Linux itself is a kernel, and it's not possible to run Linux without some sort of distributions. And these distributions are usually free, so you can always switch and swap these distributions to find the right one that fits you. And examples of these general purpose distributions would be Ubuntu, Elementary OS, Arch, Manjaro, Pop! OS. And there's also some security focus in mind for these distributions. So not all distributions are built equally. So if you're a beginner, you would usually get recommended to use Ubuntu, since it's very simple to get started and it's pretty stable in itself. So moving into its security, so Linux it has less than 3% of its market share for operating system compared to Windows, which operates more than 80% of its devices. There's less chance of a large scale attack since there's a smaller audience for Linux. Linux users are more security conscious, so they're able to spot vulnerabilities faster than their competitors, since a lot of operating systems such as Windows and macOS, they have to go to this business hierarchy in order to get things approved and send all these updates. Whereas Linux, it literally is just open source. So once you send a pull request into their repository, it gets checked by a maintainer and gets pushed into the stream. And social engineering will always happen no matter what operating system you use. So no operating system is really safe than others. It's just that there are some operating systems where they put some safeguards in place to potentially prevent it from happening. So moving into its privacy. So again, there are distributions that focus on privacy in mind, and it doesn't have as much bloatware, although there are software that can be removed from its operating system if you wanted to, and an operating system as in distros. And it doesn't lock you out on the options for data collections and stuff like that, like Windows, where you see here there's a toggle button that's literally disabled for no particular reason. Distros like Ubuntu will collect anonymous data on you, such as what version of distro, hardware display, and time zones. But anyone can actually verify what they're actually collecting, unlike Windows and macOS, which is the closed-based operating system. So you don't really know what kind of data they're actually really collecting, and you really just have to trust their word for it. Whereas Linux, you can actually check the code base itself. So what Linux is great for? Legacy computers. So if you have a old computer that's not kicking as is usual, you could install Linux and treat it like it's new, since it's usually lightweight compared to Mac OS or Windows. And it's great for programming, such as since there's Bash and Shell terminal on there, and we all know how famous the Windows command prompt is. Um, Linux is built for scripting and automation at its core. There's a lot of customization to make it a quicker workflow, and it's much easier to access the tools compared to Windows and maybe even macOS. And Linux is also known for its servers. So in 2021, 100% of the world's top 500 supercomputers run on Linux, and around 96% of world's top 1 million servers run on Linux, and 9% of all cloud infrastructures operate on Linux, and practically all best cloud hosts use it. So why isn't the average person using Linux? It's availability, right? Almost you can't find a computer vendor that actually has Linux pre-installed. And usually there are some outcasts where they'll give you options to install Linux instead of Windows, but it's very rare. Its reputation for Linux, it's mostly gatekept by programmers and tech savvy people. So the average person wouldn't really try out Linux because of maybe that reason. The technical support, so you won't find much support outside of online resources to help you if you need help within your computer. And that's what kind of turns some people down when it comes to using Linux. The complexity of it, the average person just wants a simple operating system to just work. Most of the things you do on Linux, you have to go into terminal, put in some commands in there, and the average person doesn't want to do that. It's kind of overwhelming to even use the terminal itself because you might potentially break something, and you have to do that whole routine again and to get someone to fix things and stuff. And due to its customization, it causes complexity to the system, and a lot of people just want an operating system that just works, like macOS or Windows. And then gaming, right? There isn't a high demand for gaming within the Linux community, so it doesn't really motivate publisher to actually publish games that supports the Linux kernel. And yeah, so that's pretty much it for Linux.
Social media and search engines. Safely using social media. You must always set your profile to private. Being public means that anyone can see what you are posting, and it is more harmful than you might think. You need to ask yourself, who wants to see your posts? And keep in mind that anything you post can be shared with others. For example, if you're out partying and you have close friends or family that are pretty close to your parents and they don't know that you're out there doing that, and of course you might not want them to see that, whatever the case may be, but you should always keep in mind that it will probably be shared with them. So protecting your identity, of course, this is the most important one, and it should be common sense, but your privacy is important, and people tend to overshare on social media. Never share personal things such as your phone number, passwords, or address. Continued. Avoid big risks. Sharing something private of yourself, like a private image or a private video that nobody should be seeing, or maybe except for one person, whatever the case may be. But yeah, things can go wrong, or it can be in the wrong hands, and once it's out there, it's impossible to get rid of it. So maybe think twice. Yeah, think twice about sending something private out there. You must always verify who you are connecting with. There are so many fake accounts or just random weird people out there that will try to scam you or cause harm to you in some form of way, and you should always verify who you're communicating with and be wary of them, since most of the time they might be trying to commit fraud on you. Continued. Knowing when to take action. So there are instances of someone bothering you on social media. It happens. There's a lot of weirdos out there. They can be harassing you or even sending threats to you. Blocking them is your best choice so that they don't have access to you anymore. And also reporting them. Another thing too is do not believe everything you see. Most people tend to think that everything out there on the internet is true in some way. But you might believe that there is a link that is safe, but in reality it can contain harmful software or it's an attack on your privacy. Many things look suspicious, such as profiles claiming they sell items like shoes or claim they do giveaways, but they are just mostly scammers. If it seems too good to be true, it's probably more likely harmful. What are search engines? Search engines are software systems that are used to initialize web searches, to search the entire web for specific information in text to a search. There are popular search engines such as Google, Yahoo, and Bing, to name a few. They typically work in discovering and organizing the internet's content to better provide the most relevant results for the questions the user is asking. How do they work? Crawling. So there are three primary functions that search engines work through, and the first is crawling. For example, in a Google search, the web is automated with programs called crawlers. These crawlers are searching for pages that are either new or have been updated for the latest information. They are continuously scouring the internet for the content and are looking over the code for each of the URLs they find. Indexing. This is the second primary function, indexing. By this function stores and organizes content that is found during the crawling process. So as a page in the index, it is running to be displayed for the user to relevant queries. It goes through the databases and whatever it is that you search for, it is going to try and look and be displayed on what you looked for. The third and last primary function is ranking. Ranking provides the pieces of the content that will be the best answer for the user search, and the results are going to be ordered by the most relevant to the least relevant. The search engine looks at the index for the highly relevant content and orders that content. How to safely use search engines. To use a search engine safely, you must first use a legitimate one such as Google. There are many fake search engines out there. You have to be careful what you search for, and of course, common sense, do not type your name, social security address, or anything personal. Using different search engines can help over a long period of time, since if you only use one continuously, someone could be able to see what you've looked and searched for over the last few years. And contrary to using multiple different search engines, there might be different information from time to time, making it much harder. Deleting cookies is another good thing to do since they correlate with a variety of information. Another thing too is encrypted searches are another good way to be safe, especially on mobile devices. You can use HTTPS as a safe way to search.
Hi, my name is Justin Mendez, and I'll be presenting the topic of privacy-focused hardware. So first off, we'll cover laptops, and then we'll go over phones. But for some security features in laptops that are popular, and some brands that are popular, and one of them that's kind of like a well-known name is Purism, and they're a pretty popular security and privacy-oriented company. And some of their like pillars or missions are to be dedicated to freedom, privacy, and security. And some main devices that they or products that they have are the Librem 14, the Librem Key, and then the Librem 5. So the 14 is the laptop, and the key is a USB security key, and then the 5 is a smartphone. So in the laptop, it has core boot BIOS. It has physical kill switches, which disconnect the camera, mic, wireless, or Bluetooth. And then on phones, it could also do the cellular data as well. And then also for the laptop, there's They also offer a security service to prevent and detect interdiction, and I'll go over that in the next slide. And also in the later slide, I'll go over Pure OS, which is a Linux distribution based off of the Debian distribution. So, lastly, on this slide, it's the Librem key. It's a USB security key. So it holds keys secure and has software to detect tampering, and disables the Intel management engine. And it has write protected BIOS and EC chips that use hardware switches for added security. So we can go into the what those features really mean and why they're important. So Core Boot BIOS is, or it's actually mainly just called Core Boot, but Core Boot is an open source replacement, often for the UEFI firmware on most computers, and it's designed to perform only the minimum number of tasks necessary to initialize the hardware and work with other secure software and open source, in fact, in order to boot the computer. As for the Librem security key, the USB chip, it's write protected BIOS and EC chips that are chips like hardware switches that are in it, and they're connected. They like interface with Core Boot to add a much stronger BIOS security compared to EFI and UEFI firmware. This feature avoids a copy-paste exploit in the UEFI boot sequence that allows someone to compromise an entire system, thus increasing the security of the system as a whole. Another topic previously mentioned was interdiction, and this refers to laptop or cell phone or any type of product that's being intercepted between when it leaves the fulfillment center and the time you actually receive and use the product and boot it up for the first time. And so to prevent this, companies like Purism and others, they really try to control like the line and how the products are made, and one of them is the packaging. And so there's specific packaging details that a customer or consumer must take note of when they're getting the laptop, in order to tell if their product has been tampered with. So they could be like the certain screws on the bottom of the laptop, like how the packaging, if it's they see any noticeable like openings or stuff like that, where you can physically tell that someone's been tampering with your device before you receive it. So some other phone options, like I mentioned before, the Librem 5, and other phones that are more privacy and like security oriented, and they offer certain features that help with that. So the Librem 5 is from Purism again. It's focused on those two main topics, and they have hardware kill switches like the laptop, the Librem 14 from the same company. It runs on Pure OS, which has several layers of protections and settings that disable trackers and other stuff that people don't like being tracked. Next, we have the Fairphone 3. It's an Android-based smartphone whose maker's coverage focuses on their supply chain and repairability, both of which are important when it comes to security and user experience. And as well, you can install your favorite alternative operating system if you want. Lastly, we have the Pine 64 PinePhone. It's a Linux-based alternative to the Librem 5. Key strength is that it runs on an open source OS by default, and software as well. And as well as all three of them, actually, you can install any supported operating systems for when you get the phone, which gives a lot of customization to the consumer. And now we can talk about Pure OS and Pop OS. So Pure OS is found on like the Librem devices and and all those devices can interface with each other better because the same company and they're on the same operating system, right? So the 11.5 uses this by default, and it is again based off the Debian distribution. It can connect with other Purism devices to have better connectivity and features, and this operating system has trackers and other forms of breaches of privacy disabled from the start. And another popular or pretty popular OS is called Pop OS, and it's another operating system that runs on System 76 laptops, desktops, and other products. And this company is also known for having privacy and security as pillars of the software used in the products they create. And of course, Pop OS does not collect or store any info from user installations, and minimal OS and hardware data is used, not stored, to provide updates and connectivity verification. And of course, there's more other features that and for Pop OS that increase user security and privacy.